Hi there, folks. Today we're looking at quadratic values and their graphs. And we've already kind of looked at quadratic values in terms of solving quadratics and that kind of thing. We've looked at graphing quadratics, but now we want to kind of bring all that stuff together. All right. And really, there's nothing new here today that you shouldn't already know how to do. It's just understanding what we're supposed to do in this context, in the context of parabolas, okay? So we're going to find things like we've already found, like the vertex, the axis of symmetry, but then we're going to do a little interpretation with vertex and axis of symmetry. We're also going to find x and y intercepts, which is a concept we understand, but we've only really applied it to linear equations. Now we're going to apply it to quadratics, okay? So as I look at this first one, I've got y equals x squared plus 2x minus 3. The first thing I should recognize is that that is in standard form, all right? Because that dictates how I go about finding some of these values. So if it's in standard form and I want to find the vertex, well, I have to use my formula opposite of b over 2a. So in this one, the opposite of b is a negative 2 over 2 times a, which is a 1. So it's a negative 2 over 2, which that is a negative 1. So that's the x value for my vertex. But I have to plug that back in and find the y value. And again, that's like I'm doing a piece of an xy chart over here. So I plug the negative 1 in. And just be careful here. Negative 1 squared is a positive 1. Here that's a minus 2 and a minus 3. So it looks like a negative 4 when it's all said and done. Okay? And I'll leave that xy chart off to the side. Maybe we'll need it. Maybe we won't. Okay? If we want to graph this pretty accurately, we might need some extra points. And then axis symmetry is just x equals the x value from the vertex. We already knew that. But now we want to interpret this thing. And so before we even graph, we want to think about what this vertex represents, whether it represents a maximum or a minimum value. And really, we can determine that by looking at the a value. When I look at this guy, the a value this time is a positive 1. All right? And so if the a value here is a positive 1, it means this parabola opens up, which means the vertex on this one is going to be a minimum. And so that's almost counterintuitive sometimes to students, but think about it. If the parabola opens up, the vertex is at the bottom. If the parabola opens down, the vertex would be at the top. Okay? And so when the parabola opens up, the vertex represents the smallest value on the parabola. When it opens down, the vertex is the very tippy top, so it represents the largest value. So this one, again, it's a minimum value because of where the vertex is. Okay? And we'll talk about that minimum value in terms of the y value. So we'll say the minimum value is a negative 4 on this one. All right. And again, that's going back to talking about like domain and range here. All right. The domain of this parabola is all real numbers, but the range is defined by that maximum or minimum value. If the smallest value I have is negative 4, if the lowest it goes is negative 4, it means the range is y is greater than or equal to negative 4. Okay, and so we're talking about range just a little bit when we look at this guy, okay? And now x and y intercepts. Again, this is a concept we understand, but from the perspective of lines, well, it's the same thing here. When you think about to find the y-intercept of any function ever, you plug a 0 in for x. That was true for linear equations, and it's true here. To find the y-intercept, you plug a 0 in for x. And so for this one, if I were to plug a 0 in for x, I've got 0 squared plus 2 times 0 minus 3. And as I simplify that, well, a lot of stuff goes away. I'm just left with a negative 3. And so the y-intercept, it was a 0 for x and a negative 3 for y. I write it as an ordered pair. Okay? So this is very similar to what we did with lines. Just my approach maybe to solving might be a little bit different. Okay? The x-intercept is the same kind of thing. The x-intercept for any equation ever, I plug a 0 in for y. Well, here, if I have a 0 for y, I end up with this. Equals 0, okay? And so the only thing that's different here, actually, let me give myself a little bit more space. If this was a linear equation, I'd go right to solving by undoing order of operations and whatnot. But because this is a quadratic, I have to think about the ways I know how to solve quadratics. For solving a quadratic, we have 3 methods. Factoring, completing the square, or the quadratic formula. And so remember, solving a quadratic, I always want to check factoring first, so I always build a bridge. I see if I can come up with the 2 numbers. So here I build a bridge. That was terrible. I'm ashamed. Oh, that's a pretty good looking bridge. There we go. So 2 numbers that multiply to a negative 3, but add to a positive 2. So I'm looking for two numbers to multiply to a negative 3 to add to a positive 2 is a positive 3 and a negative 1. And so because I can come up with those two values, if I can come up with those, it means I can factor this thing. And this one's a great one for factoring because look at this. The a value is a 1. That's where I get to use my shortcut. So this guy factors into an x plus 3 and an x minus 1. But that's the factored form. If I want to solve by factoring, I have to set each of these equal to 0. So I do x plus 3 equals 0. I also do x minus 1 equals 0. And then hopefully, I think most of us can solve this in our heads. Subtract the 3, you get a negative 3. Add the 1, you get a positive 1. But keep in mind, those are two separate points. They're two separate ordered pairs. So I got a negative 3 for x when I plugged a 0 in for y. I also got a positive 1 for x when I plugged a 0 in for y. So because I get two different x values, that's two separate ordered pairs. Okay? And so now let's summarize the work that we've done so far. Let me circle the things we're going to graph. This guy, okay? We'll graph the axis symmetry. This one's more just for kind of interpretation purposes. We know that the vertex should be at the bottom, so we'll double check that. But then we'll plot this point and we'll plot these points, okay? And see what we get here. Okay, so let's see, negative 1, negative 4 is down here. The axis of symmetry is right here. I can go ahead and plot the y-intercept. That's a negative 3 right here. And now because of my axis of symmetry, I can reflect that point on the other side. And now the x-intercepts, let's see, negative 3, 0. And 1, 0, and those are actually reflections of one another as I go to interpret this thing. And as I look at this, the parabola has pretty much taken shape. Yeah, maybe I want an extra point or two, so I could go over 3 up 9 and use my a value, or I could plug in another point over here. I could plug like a 2 in or something like that. But really, there's enough information to graph here. I can kind of see what this looks like, and it's going to be fairly accurate. Okay. Now, will all these values that I just found always be enough to give me a really accurate graph? Well, not necessarily. It depends on where the points fall and if the x-intercept is the same as if the y-intercept is the same as one of the x-intercepts, that kind of thing. So, we just have to kind of take this with a grain of salt. Yeah, this time, finding all that stuff was enough to find these pieces. Okay? But the idea here is we want to find this information because these represent very specific things when we're talking about interpreting these and when we start to get to word problems, okay? And yeah, this time it was enough to give us a nice accurate graph. If I look at this one, same kind of thing. It's in standard form, so because it's in standard form, this is going to be opposite of b over 2a for this guy, so I'm going to do opposite of b over 2a. Let me draw a little squiggle here to separate that. So the opposite of b is a positive 1 over 2 times a, which is a 1/4. And I simplify, that's 1 over 1/2. And so that's a positive 2. All right, and be careful, of course, when you're dividing by a fraction. So that's the x value for the vertex. Again, a nice little xy chart over here. We might need some more points. We might not. But as I plug these in, 2 squared is a 4. Just be really careful as you plug this in. 4 times 1/4 is a 1, so I get 1 minus 2 minus 4. So that looks like a negative 5. Okay? The axis of symmetry is always x equals the x value from the vertex. And then once again, I interpret this. I'm going to interpret this vertex and say, hey, you know what? The a value right here is a 1/4, so that's positive, which means the parabola opens up. So think about where the vertex is. The vertex is at the bottom. This one's going to have a minimum value. And once again, the minimum value that I get is a negative 5. Again, it's interpreting, it's telling me a little bit about the range of this thing. The domain is all real numbers, but the range is y is greater than or equal to negative 5. If negative 5 is the smallest y value, all right, then the y values have to be negative 5 or more. Okay, that's talking about the range. It's talking about the y values being used, okay? For the x and y intercepts, once again, we're looking at this from the perspective of, okay, I know algebraically how to find each of these. To find the y-intercept, I plug a 0 in for x. And so once again, if I plug a 0 in for x on this one, and you're probably looking at this going, I can do that in my head, Mr. Jansen. I don't need you to write 0 for each of these. Oh yeah, y is going to equal a negative 4. And if you notice, there's a little bit of a shortcut that we can use for that. When you look at the y-intercept from the previous example, it was a -3, and look at the c value. Oh, that's a -3. If you look at the y-intercept here, it's a -4, and look at the c value. Oh, it's a -4. Yeah, in standard form, the c value will always be the y-intercept, okay? Because as I plug a 0 in for x, that's all I'm left with, okay? And so now the x-intercepts, I plug a 0 in for y, so once again, that's going to be a 1/4 x squared minus x minus 4 equals 0. So I plug a 0 in for y, and now I want to solve this, factoring completing the square or the quadratic formula. As I look at this thing, I'm not excited about any of those because of that 1/4 out front. So that's the first thing I'm going to do. I'm going to get rid of that fraction. Remember, you can always get rid of a fraction by multiplying through by the common denominator. Multiply everything by 4. Make the fraction go away. X squared minus 4x minus 16 equals 0. And now that's a much easier quadratic to look at if I'm talking about solving. Okay? And so here, I would build a bridge. Build a bridge, two numbers that multiply. Let me write it over here. Multiply to a -16, but add to a -4. I hear crickets because there are none, all right? You start thinking about factors of 16. You're like, okay, a 4 and a -4, that's not going to work. A 2 and a 16, making one of those negative, that's not going to work. A 2 and an 8 and a 1 and a 16. None of these are going to be able to give us a -4. This one can't be factored, okay? So if factoring doesn't work, I move on to either completing the square or the quadratic formula, okay? If I'm going to do completing the square, let me take that over here. If I do completing the square, remember I just add that 16 to each side. Give myself a little space. And now I do b divided by 2 and square it. That's a +4. Whatever I do to one side, I have to do to the other side. And now it's a little bit of factoring. That's x minus 2 squared equals a 20. I take the square root of each side. Don't forget your plus or minus when you do that. So that's a plus or minus square root of 20. And I'm going to add that too. Okay? And so when I look at this, here's the answer I get. And so if I was doing this from the perspective of just solving, I would write my answer as 2 plus or minus the square root of 20. Well, really, I would simplify that square root of 20 because there's perfect squares divided evenly in there. But for this particular example, that wouldn't be a great way to write this answer, all right? It wouldn't be good to list my x-intercepts as 2 plus or minus the square root of 20 or 2 plus or minus 2 root 5. All right, that's not a good way to write this thing. This is a situation where context becomes very important. If the context is I want to graph this, well, I don't want square roots. I don't know where that is on the number line. All right, I want to plug this into a calculator. And keep in mind that plus or minus means I have two things. So I have to do 2 plus the square root of 20, and then I have to do 2 minus the square root of 20. And this is why I didn't bother simplifying the square root, because my calculator doesn't care if that square root of 20 is simplified. So 2 plus the square root of 20 on my calculator gives me a 6.5. And so up here, that's 6.5 for one of my x-intercepts. And now I do 2 minus the square root of 20 on my calculator. And when I do that, it gives me approximately a -2.5. Okay? Well, that's terrible looking. Oh, I erased too much. There we go. And so that's a better way to write this answer. Let me real quickly do this with the quadratic formula as well, because some of us aren't big fans of completing the square. So quadratic formula, the opposite of b, plus or minus the square root of b squared minus 4 times a times c. And we just have to be really careful. All over 2a. As we simplify, that's 4 plus or minus the square root of, that's 16. And that's going to be a plus 64 all over 2. So we end up with 4 plus or minus the square root of 80 over 2. And again, don't bother simplifying this. Don't bother simplifying that square root of 80 and that kind of stuff. We'll just plug it right into the calculator. 4 plus the square root of 80 gives me 12.94 something, and then divided by 2. Oh, look at that. I get a 6.5, just like I did before, okay? And then separately, I'm going to do a 4 minus the square root of 80, which gives me a -4.94 something, and then divided by 2 will give me the -2.5. So again, just plug this into a calculator. Make sure that when you plug it in, you do 4 plus this guy, hit enter, and then divide it by 2, or put it in parentheses. 4 minus this guy, and then hit enter, or put it in parentheses and then divide by 2, okay? That's the only way it's going to do the problem correctly. But again, I get these decimal approximations. So here we go. Here's all the information I have. I know it's a mess here, the vertex, the axis of symmetry, y-intercept, and the x-intercepts, okay? I did the problem twice, all right? Caused myself some headaches in terms of what's down there. But as I plot these, ready? 2, -5. The axis of symmetry, which helps me reflect points, which is always good. The y-intercept at -4, it's right here, and I can reflect that point over on the other side. The x-intercept's at a 6.5, right here, and a -2.5. And once again, those are reflections of each other. And here's the thing, if those aren't reflections, it means we've done something incorrectly. We should go back and fix it. And so as I look at this, that's enough information to graph. I don't think I need to do anything else on that XY chart. I can kind of see the shape of this parabola. It looks pretty accurate, all right, because I have a couple points that are nicely spread out, okay? If I look at this one, this one is in vertex form this time, so it's not standard form, so I have to change my perspective, okay? No opposite of b over 2a for getting the vertex. Remember, in vertex form, the vertex is given. It's always the opposite of this guy and this guy exactly the way it is, okay? So the opposite of that +3 is a -3, and then I take the +2 exactly the way it is, so I put a 2 down, okay? That's how we interpret this thing. Remember, it's the opposite of the thing with x. The thing on the outside we take exactly the way it is. Axis of symmetry is x equals the x value from the vertex. That's a -3. And now once again, maximum or minimum, look at the a value. The a value this time is a -1/2. So because that's negative, it means the parabola opens down. So if the parabola opens down, think about what the vertex is. It's at the very top. So it's going to be a maximum. Okay? And again, we describe the maximum value in terms of y. It's got a maximum value of 2. And again, that's telling me about the domain and range. We know the domain is all real numbers for a parabola, okay? It goes forever in each direction, left and right. But the range now, if that's the maximum, it means the y value, y is less than or equal to 2, okay? And then the y-intercept isn't quite as easy. It's not the 2 that's over there because this is not standard form, okay? Here I have to plug in a 0 for x, and I have to simplify. I plug in a 0 for x. It gives me a -1/2. Sorry, that's terrible looking. Here that's 3 squared plus 2. I do the exponent. And again, just write it as a decimal. -4.5 plus 2, that's a -2.5. Okay? So that was this, 0, -2.5. Okay? It makes the most sense as a decimal because I want to graph this thing. And now to find the x-intercept, I plug a 0 in for y. And when you look at something like this guy, if that equals 0, this is set up kind of like completing the square. It's set up to solve using my square root. I just have to work backwards sort of operations. I'm going to subtract the 2 from each side. I'm going to multiply each side by a -2 to get rid of that fraction. And now I can solve using the square root. I take the square root of each side. So I get x plus 3 equals, oh, sorry, I don't need the parentheses, plus or minus that 2. And so then I subtract the 3 from each side. Running out of space a little bit. But again, I don't leave it like this. It's not -3 plus or minus 2. It's -3 plus 2, which gives me a -1, and -3 minus 2, which gives me a -5. So I get 2 x-intercepts. Write them as ordered pairs. Ready? -5, 0, and -1, 0. Okay? And now let's graph this stuff. Let's see what it looks like to see if I have enough information to graph. Got vertex, axis of symmetry, and the intercepts. Negative 3, 2. It's right here. 0, negative 2.5 is right here. Oh, sorry, I forgot my axis of symmetry. And again, my axis symmetry is important because it just gives me a visual for reflecting this point. See, now I can reflect this point. My parabola is starting to take shape. Negative 5, 0, and negative 1, 0. And once again, those are reflections of one another. Well, this is enough information to graph. I can kind of see what this thing looks like, and it's fairly accurate. Okay. If I want more ordered pairs, I go to an XY chart, or I use my A value to help me out. Okay. For these guys, we just have to kind of interpret some of this. All right. This question is just asking us to do the stuff we know how to do, but it's interpretation. All right. And this is really a physics question. So it says the equation h equals negative 4.9 t squared plus 6t plus 1 represents the height h in meters of a ball thrown into the air after t seconds. Okay. So when I think about my input-output here, instead of x and y, I have t and h. All right, t ends up being like the x value, and h ends up being like the y value. And again, t is the time, and h is the height. And so I want to think about it from that perspective of input-output. But then as I read these questions, I have to just figure out, well, what is it asking me for? Is it asking me for the vertex? And if so, which value from the vertex? It is asking me for the y-intercepts or the x-intercepts, that kind of thing. Okay. And so as I look at this first one says, what is the starting height of the ball? Okay, so it says, what is the starting height? So it's asking me to find h, which means I have to plug something in for t. And so as I think about this, the starting height, like if you started a race, if you look down at the stopwatch at the start of the race, what's the value on the stopwatch? How many seconds have passed? And the answer is 0. Okay, so the starting time, you already know, the starting time will always be 0. So now I'm trying to find the starting height. So really it's asking me for the y-intercept. If you were to plug a 0 in here for t, now I can solve for h. So h equals a positive 1, and that's 1 meter. And so when you think about it, as we're starting to interpret and think about how this thing works, it means that as we threw the ball in the air, it was released from somebody's hand at 1 meter high, which kind of makes sense, and it was thrown into the air. Okay? Here it says, what is the maximum height of the ball? And see, the key word here, when we're trying to figure out what piece are we trying to find, are we trying to find the y-intercept? Are we trying to find the x-intercepts? Are we trying to find the vertex? It's the idea that it says maximum right here. And maximum, that should be associated with a specific part of our parabola. The maximum is going to be the vertex, okay? And since it says maximum height, see, when we think about the vertex is two values, right? Well, this would be t and this would be h, right? The t is what I plug in, the h is what I get out. So it's asking me for the y value from the vertex. And so it's that idea of just interpreting. Maximum is associated with the vertex. Well, this is standard form, so to find the vertex, I do the opposite of b over 2a. And again, this is a job for my calculator. I don't expect you to sit here and do that by hand. Negative 6 divided by 2... a negative 9.8. So I get something that looks like 0.6122, and that keeps going or whatever. All right, just round it off. That's okay. All right, a couple decimals isn't going to hurt anything. That's the time. So to get to the maximum height, it's a time of 0.6122 seconds. But now I have to find the other half of this ordered pair. See, I have this guy. The thing I'm looking for is this guy, so I have to plug it back in. And when you plug things in, you always use parentheses to plug them in. Makes things much easier. Science teachers would be upset about my significant figures here. All right, but that's okay. But now, this is a job for my calculator. And if you use parentheses to plug stuff in, you can punch this in exactly the way it's written. Sorry, I'm punching it in right now. And so when I punch this in, I get h equals 2.84. I'll just round this to 2 decimal places. Now I'm really messing with those science teachers. They'll tell you all about significant figures. So as I look at this thing, it was the time and then the height. This is meters. And as I interpret this, all I wanted was the maximum height, okay? Next question says, when will the ball reach the maximum height? Okay, well, we already found the maximum height, right? The maximum height was 2.84. It's asking me when, how long will it take? Well, I already answered this as well. This is an interpretation piece from the previous question, okay? And so as I look at this, I already answered this. How long is it going to take to get to that maximum height? About 0.61 seconds, okay? And yeah, I rounded it off more than I did before. I kept more decimals to keep the second half of my vertex a little more accurate the first time. But now it's asking me for the first half of my vertex. So again, the idea here is just interpretation. What is it asking me for? Which piece of the parabola do I want? Okay? And then this one, it says, when will the ball hit the ground? So when, it's asking me to find the time. When the ball hits the ground, well, that's a height of 0. Okay? And so as I plug this in, if I plug a 0 in for h, and I want to solve for t, this is essentially the x-intercepts, okay? Yeah, it's t this time, so it's the t-intercepts, okay? But I'm doing the same thing. And the easiest way to do this one is going to be quadratic formula, so opposite of b plus or minus the square root of b squared minus 4 times a times c, all over 2a. And now this is a job for my calculator. Okay, yeah, that's 36. I can do that part. But here, do the 4 times 4.9 on your calculator. Don't stress about trying to do that in your head. Again, you can do that denominator in your calculator as well. So here's what I have, but I don't want to leave it like that. I want to plug each of these in. I want decimal approximations. So I'm going to do negative 6 plus the square root of 55.6. And again, in parentheses, or make sure you hit enter on your calculator before you divide by the negative 9.8. And then do the subtraction as well. And we'll see what our calculator gives us. So when I do the plus version, I get this. Negative 0.149. And when I do the minus version here, I get 1.373. And so as I look at this, these are supposed to be times. This is the number of seconds, okay? This is also the number of seconds. Only one of these makes sense, and it's this one, okay? Now, why do we get that negative? Well, think about it in terms of the graph. This parabola started here and went up into the air and came back down. So really, back in time would be this guy, okay? So it's finding that other x-intercept, even though it doesn't make sense in the context of this problem. This is the one we want, okay? So the 1.373 seconds. So again, you have to read the context of the problem and figure out, well, which value from the parabola is it looking for? Are we looking for the x-intercepts, the y-intercepts? Are we looking for the vertex? And if so, which piece, okay?